Okay, let's conclude this chapter by running through some climate-related civilization impacts, not so high on health directly, health-related issues, but Mayans, which thrived from 300 CE to about 900 CE, and then again till about 1500 CE, I think, where mostly got their diseases after the Spanish conquistadors brought diseases, and their story is mostly about the drought. The Americas, as we said, when the Pacific, East Pacific has cold temperatures, especially around Galapagos, that tends to produce a drier climate over North and South American coasts on the eastern part of the Pacific. And if that pattern of cold SSTs, sea-surface temperatures in the east persists, then obviously you have persistent dry climates over these regions. But the specific Mayan regions are also part of the so-called North American monsoon, where you remember the ITCZ that comes up here towards the Gulf of Mexico, because it's very warm. But the as you move latitudinally, rain is much more on the ocean than on the land, and when the ITCZ moves, you are going to create drought patterns over these regions as well. So it's not just related to La Nina, but indirectly is related to La Nina as well. The main lowland and highland classic Maya centers are shown here. The civilization spanned all or part of today's Mexico, Belize, and Guatemala, Honduras, and El Salvador. So you see Gulf of Mexico is here. You can look up the sea surface temperatures, which is almost as warm as tropical temperatures, and it's, I think you get some of the northernmost corals in these regions, and warm temperatures are typically conducive to atmospheric convection, rainfall, and so on. So here you have Mexico, Maya highlands, Maya lowlands, Belize, Petén area, and so on and so forth. So the demise of Mayans is mostly a climate story, but as I said before, it does always relate to droughts, famines, nutrition, food, and eventually health, of course. So in that sense, it is part of the climate and health story. And you can see here now, going into the classic Maya civilization annual rainfall, going from 300 CE to about 1200 CE here. Estimated annual rainfall from oxygen isotope ratios in stalagmite microslivers. So when you have rainfall and groundwater seeps into caves and creates these stalactites and stalagmites, there are oxygen isotopes that are related to the amounts of rainfall that leave signatures in the caves, in these stalactites and stalagmites, which can be used to estimate rainfall variations with some low frequencies. They are not highly resolved because that drip is very slow, but you do get low frequency signals. So here you have dips in 770, 825, the big one in 910 approximately. It's not an exact match, and there is a broad dip in drop in estimated annual rainfall. So it is known, climate people tend to correlate events like civilizations and their demise and their expansion, shrinking, and so on with climate events, but anthropologists and social scientists would say that it's not always that direct. Climate is like a barbarian at the gate, which you need multiple hits before the civilizations go belly up. For example, Mohenjo-daro, Harappa, the Indus Valley civilization survived for a while, and as monsoon dipped, they migrated around, switched from single season agriculture to two season agriculture because winter monsoon was doing better. They tried rainwater harvesting. Same thing happened in South America. You can see, go to Machu Picchu and find fog harvesting structures, water harvesting structures, and so on. So people try to deal with water stresses, but if they persist and if they keep getting repeated, then obviously they may not be able to survive. So health is a part of the story. Plague came back so many centuries later, 1347 AD to 1351 AD. Again, the story is that it originated somewhere here in China and India and was brought to Europe and killed somewhere between 25 million and 200 million people around the Mediterranean and European regions. Was that related to climate? Climate variability. So there are patterns, changes, but here you have trade routes, mice hitching a ride with the trade routes, and then entering new regions, and then trying to adapt food availability, human contact, and then human price paid through plague outbreaks. Obviously, Black Death is a big event in human history. This is kind of the transition from the medieval warm period into the Little Ice Age that evolved over this part of Europe, and there was changes in agriculture, seasonal patterns of rain, and food production, which typically affects mice when they go looking for food and carry the fleas with them, and so on. Okay, moving forward, this is the Anasazi in the western US, which right now is facing massive droughts, multi-year droughts, a monumental heat wave, and again, history seems to be a analog. So we are looking at drought index here from lake sediment oxygen isotopes again, and whenever you are below this zero line here in terms of the isotope ratio, you have droughts. So the Anasazi demographic changes happened during these massive droughts. So variations in drought conditions over 2.5 millennia based on lake floor sediment isotope profile from Pyramid Lake, Nevada, in the United States Southwest. The 3 droughts centered on San Juan Basin region are shown here, based on this figure from this paper here. But again, climate impact on droughts, you can see this here, Anasazi, Hohokam, and Mogollon, and also the Cahokia and the Mississippi culture. Massive, this is something called Palmer Drought Severity Index, which uses temperature and soil moisture to estimate the severity of the drought, and you can see a hotspot there, but it's quite widespread here. And range and severity of the mid-12th century drought in Southwest America. Approximate locations of the 3 main Pueblo peoples are shown, as is the Cahokia and Mississippian settlement. Okay, so this is another climate-driven agricultural production, nutrition, food, health connection that'll then lead us to the next part, which is on the Little Ice Age, which I mentioned in the context of this transition during which the Black Plague happened. So there seems to be a tight relationship, at least anecdotally, between climate variability on low frequencies, so secular trends, and epidemics. So there's a big debate about whether COVID is really related to climate change or not, but that's a more complicated issue in terms of human diets, contact with bats, or whether it was something that escaped from the lab. This debate will go on for some time. Proof may never be found for one decision on one way or the other, conclusion one way or the other, but human movement, globalization of the economy obviously plays a big role in the way COVID gets around and multiple waves keep happening from one continent to the other and new variants emerging and getting across different continents as well, and so on. So hard to extricate the climate impacts from human movements and health outcomes, but that's what human ecology is all about.